Welcome to the session on physical measurement of flow in drains. Hi, I'm Swarna. I work with Wash Institute. In this session, we will be discussing about measuring flow in drains, which is a part of field observation and measurement methods. In this session, we will be looking at what is a drain and drain endpoint, why do we need to measure flow in a drain, what are the various methods of measuring and estimating flow in the drains, what are the expected outcomes, along with tools available to deploy each method. Drains or stormwater drain is open or closed channel generally designed along the road to drain the excess rainwater from impervious surface such as paved street, footpath and roofs. These drains play a crucial role in preventing flooding and managing surface runoff. It can be a lined or an unlined structure. The discharge point of a drain is called as the drain endpoint. It is often found that the water from drain outfalls into a water body or into an open area at the drain endpoint. In India, many towns are unsewered and therefore the used water that include grey water and the supernatant of septic tanks often find its way into stormwater drainage network. And to prevent pollution of water body, it is necessary to arrest and manage the used water flowing in these drains. In order to do so, it's important to quantify the used water flowing in the drain so that capacity of intervention required can be decided. Since many establishments utilize multiple sources of water, estimating the used water generated in the town gets tricky. Furthermore, there can be multiple drains of different size flowing in multiple directions. Therefore, it is important to measure actual flow of the used water in all the drains. There are three commonly used ways of measuring flow: measurement using a flow meter, the V-notch method and the float method. Let's discuss them one by one to find out more details about each of them. There are pros and cons of each method, and each method have certain criteria to be met and also have a level of uncertainty. For instance, V-notch method can be used for a frequent discharge measurement, but it may not be feasible to use for measurement of flow in large drains. And float method might take longer time in calculating flow. Similarly, each method has a different level of uncertainty. All these factors should be kept in mind while choosing the most appropriate method for measurement. Before deploying any method to measure flow, certain precautions should be taken. For instance, silt, blockage, debris should be removed from the approach channel. There should be no occurrence of rainfall in catchment in at least 72 hours prior to the measurement. Channel chosen for measurement should be fairly straight and uniform in cross-section. There should be no cross currents. Measurement of flow using electromagnetic flow meter and accompanying accessories. One can use the meter themselves or hire an agency to measure the flow of each drains. Things to note to deploy this method include finding a section near the drain endpoint where the flow is laminar and without any disturbance of solid waste and silt deposition. The width of the cross-section should be divided into equal subsections and the depth of each section is recorded along with the velocity. The measurement should be done several times throughout the day to calculate the average and daily flow. Flow meter uses velocity sensors such as fans or electromagnets. These velocity can then be used to calculate the flow through the channel using simple calculations. Q is calculated by multiplying the average hourly flow by the number of hours of flow per day, as observed in the drain. The result is expressed in cubic meters per day. The velocity of the used water should be monitored several times during the day for respective width and depth of the drain as shown in the data sheet. Then, average of all the reading should be taken like shown in the example. Average flow in daytime can be found by multiplying average hourly flow with number of hours. In the shared example, it comes out to be 1538 cubic meter for 19 hours. To this, the value for night is added, which is considered 10% of the daytime. Hence, the final value comes out to be 1691.8 cubic meter per day in this case. Second method is V-notch, which is a type of open channel flow measurement device commonly used to measure flow rate in rivers, streams and drainage systems. This is a simple method where a weir is added in the drain with a V-notch and the flow rate is determined by measuring the height of the water surface above the vertex of the V-notch. Things to note while using V-notch method is a weir should be vertical and perpendicular to the channel, and the intersection of the weir and the channel should be made watertight. The approach channel is 10 times the width of the channel upstream of the weir. The flow in the channel should be uniform and free from any obstructions. The level of water in downstream channel should be well below the crest, ensuring free and fully ventilated discharge. The details about this method can be found in the IS 9108. The height of the water surface above the vertex should be measured several times during the day as shown in the data sheet. And then, using the weir equation as stated, one can easily calculate the flow rate or discharge. The discharge at various intervals can be used to calculate average hourly discharge, which can be used to calculate the daily discharge, similar to the exercise done in case of flow meter. The value of coefficient and exponent can be taken from IS code 9108. One can download the supporting documents like the TOR and the example of an output sheet from the link provided in the description of the video. The third technique is simple and known as float method. A floating object is allowed to flow between 2 points in the drain. The time taken is recorded. The floating object can be a plastic ball or a bottle. A relative straight stretch of channel of about 20 meter should be used for this method of measurement. Ensure that the flow is free from obstructions and turbulence. Find average area of cross section across the drain. To calculate this, take the average of two cross section values at AA and BB. If the depth is varying, then the average of area of several subsections can also be taken. Measure the time taken by the float to reach BB from AA. The exercise should be repeated at least 3 times. Verify that the variation in the time measurement is less than 25%. Take an average of this and use it in the formula to calculate the flow. Make sure you also multiply a correction factor of 0.85 to compensate for localized flow variations. To calculate the discharge, multiply the average velocity of water with the average cross-sectional area. The accuracy of this method can be improved by increasing the distance between the 2 points or by increasing the number of observations. The details about this method can be found in IS 1192. One can download the supporting documents like the TOR and an example of an output sheet from the link provided in the description of the video. In summary, we understood that stormwater drains are used to drain out used water from the households. Hence, it is crucial to measure the actual flow in drains to estimate the actual volume of used water flowing in drains. Three common used methods include measuring flow through flow meter, Venous method, and float method. The TOR for hiring an agency and the sample output sheets can be downloaded from the description of the video. Thank you for going through this session.